Hello, class. This is a recorded lecture for section 3.2, which deals with the measurement of spread. Sometimes it's called measurement of variance as well. And so we will get started here. And here is the list of all the items in this section. We are going to skip the last two. Number 6 and 7 here with regards to the concepts in the chapter. By far the most important is this idea of standard deviation. And then you'll see that the empirical rule, number 5, is a really good kind of foundation for when we get to discussing normal distribution, which is by far the most important distribution for the general population in the world. So when we talk about the calculation of spread, there are two things. One is calculation of what's called the range. And hopefully the range is pretty straightforward calculation in the sense that what you're looking for is you're looking for the highest value or the highest data point, and you're looking for the lowest data point. And you just take the difference between the two. So basically, if you think about it, you're looking at the two extremes. We'll talk about this more in our Zoom class, but one of the things that I've told my wife I'd like to do one of these years is go teach in Honolulu in the winter, get out of Chicago. So what I did is I went on, and these have to be true because I got them off the internet, right? That this is the highest and lowest temperatures ever recorded in Honolulu. 96 highest, 52 the lowest. So you can see they have a delta range of 44 degrees. And so you'll see that we'll talk about in class the big difference between the temperature range in Chicago over a year and the temperature range in Honolulu. So with regards to calculations, it's probably one of the easiest ones. And then the next thing we'll talk about with regards to calculations is this idea of variance, when then we're going to follow it up with standard deviation. This book's a little bit different, and I'm starting to get used to it with regards to how they describe things statistically. And so this idea of variance is the idea of how far each data point is from the mean. And the variance is taking the mean, and then the idea of subtracting the data point from it. And you'll see that when we do these calculations, there is a slight difference between the variance in a population and variance compared to a sample. And I'll show you that when we get there. So the book talks about population first. And the idea is, and this is kind of a fancy mathematical equation, excuse me, but the equation basically states that the mean is the mu, that weird looking u, the Greek letter u. And basically you take that and you subtract that from each data point. And what we're doing here is we're squaring the data point. One of the reasons why we want to do that is we want to make all the points positive, because then when we add them all up, you'll get a number that continues to go up each time you add a point to it. And then we divide it by the total population size, which is capital N. And I will go through what I would call a do it by hand version when we get to sample, because that's the one that's used most often. But just to give you a feel for how to do this, and this is a good way to do it if you're doing it by hand, it's nice to make a table. And the idea here is that this is the population temperatures for San Francisco over a year. And if you compute the population mean, we add all these up and you divide by 12. And you could see that we get 57.5. So the first step is to take each one of these numbers and subtract it from the mean. So you could see 51 minus 57.5 is minus 6.5, et cetera, with regards to each one of the data points. And then the next step is to square all these, and you could see it ends up being a pot. Each one, when you square a number, either negative or positive, ends up being a positive number. And then you add all these squares together, get 169, and you divide by 12, and you can see that the variance is a little bit over 14. So when we do what we call the sample variance, the idea is a little bit different, where instead of having the whole population, you just have a sample of the population. So the mean is a little bit different. You have to calculate the mean of the sample. And in this equation, that's X bar. The Xi is each data point in the sample. And you could see that instead of dividing by the total number of data points like you do in the population, you divide by n minus 1, which is the total number of points minus 1. And so here is what the book and a lot of statisticians talk about, is when computing the difference between sample variance and population variance, there's this idea that they think the mean is going to be a little bit lower in the sample. And so they can show mathematically that you divide by n minus 1 and you get a little bit better representation. As an engineer, I never had populations when I was calculating statistics. And most of the time I was calculating statistics on my products. So what we would do is measure a bunch of data points. And our data points usually ranged with thousands of data points, even tens of thousands of data points. And so in my life, this made no sense to me whatsoever, because with the amount of data that I had, there is no difference between dividing by, say, 10,000 and dividing by 9,999. So when the numbers are big, this is completely immaterial, but statisticians make this as a big deal. So you'll see in some of the homework in this section, it'll ask you to calculate population variance or sample variance. And just make sure you use the right equation. And the bottom line is population, you divide by n, the total samples, and sample, you would divide by just n minus 1. So what I'd like to do now is jump on the whiteboard here and show you how to walk through this by hand. And as I've alluded to the fact, nobody does these calculations by hand anymore, but it's a good way to get a feel for how these equations work. And so the equation that we are dealing with here is the sample variation. And that would be the summation of the data points minus the mean squared, all divided by now n minus 1. And so in this case, we have a few numbers. We have 3, 4, 4, 5, 6. Whoops, I forgot the first number, which is a 2. So what I did is put these in order. And basically, if you went and look back on the slide, it says the company manufactured battery is testing a new type of battery for laptops, and they measure the lifetime in hours of 6 batteries, basically how long they would last, from 2 hours to 6 hours. And so here's how you do it if you did it by hand. So the first thing you need to calculate is the mean. And when you calculate the mean, you just add all these points together. and you divide by n, which is 6. And so if you did this, you would get 24 over 6, and that would give you the number 4. So our mean is 4. So here's how I, back in the day, how I would do this by hand. So here are our points. Call those xi's. That's 2, 3, 4, 4, 5, and 6. So the next thing we want to do is the xi minus the mean. That would be my column 2. And you can see how this fits into a spreadsheet real well. So this would be 2 minus 4, which is minus 2. This would be 3 minus 4, which is minus 1. 4 minus 4, which is 0. That's a nice number. 4 minus 4 again, which is 0. And 5 minus 4, which is 1. And 6 minus 4, which is 2. You can see how tedious this is getting already, right? So third column. So what is our third column? So our third column is x minus I squared. So that would be minus 2 squared. So that would be 4. Minus 1 squared. That would be 1. 0 squared is 0. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So then the next step is take this column and add them together. So if you do that, that is doing this in the equation. So when you do that, you get 4 plus 1 plus 1 plus 4. I didn't put the zeros in there, and you get 10. And the last step is 10 over divided by n minus 1. And so that would be 10 over 6 minus 1. And that would be 10 over 5. And so you could see that the variance for this sample is 2. So that's, excuse me, that's how you do it by hand. So to take it and show you what to do with the spreadsheet, I think what I'd like to do here is, okay, so this was the problem we just did. You'll find that in the slides. So if I jump to our class and hit assignments. And let me show you how I would do one of the homework problems in section 3.2. And so let's take this one, for example. It's asking for the sample variance, and then it's asking for the sample standard deviation. So let me take this to do the variance first. And so basically you hit that link and the spreadsheet comes up. So that's really nice. So the idea here is I'm going to stick a column in there and walk through the calculations. So this is the data set, right? And so now we need the mean. And so what we could do to calculate the mean is highlight that and go over here and do average. And you can see that the mean is 20.5. So the strategy here is the data minus the mean is this one. And so basically you would take an equal sign and the data point, and then you subtract, and the mean is 20.5. So we'll just type that in. And then you copy and paste the formulas like we've been doing. And now you have each one data minus mean. The next one would be square it. So this would be the square. And there is a squared function, but what I do in the math world is that you highlight the number that you want to be squared, and the little caret, which is shift 6, and then 2 means squares. You square each one of those numbers. And to me, that's a little bit quicker to do, but you can go up to the functions and find a square function as well. Copy all those formulas, and now you can see we have the square. So now we need to sum those together, right? So this would be summing them together. So you highlight the column you want summed and hit sum, and it ends up being 325 and a half. So the last calculation here would be the variance. And what is that? Well, in this case, it would be this number, which is the sum of the squares. And then how many data points do we have? We have 2, 4, 6. So what do we want to divide by? We want to divide by 5. And so now we have a variance of 65.1. And so this illustrates how to do it on the spreadsheet as well as doing it by hand. And I have to say that the more I'm looking at this book, the more I don't like it. But, and you'll see there's something in this section when we get to the empirical rules that is untraditional in a standard book. But on the other hand, I do love the capability for my students to be able to download the data to a spreadsheet and do these calculations instead of you even having to type it all out, which was what we had to do in the last program that we used. So this ends the first part of the lecture in section 3.1, and I will continue. The next part will be talking about standard deviation.